In this video, we want to talk about how to solve a quadratic equation by completing the square. Completing the square is a very important method, not only in the solving quadratic equation. We also use this method in calculus class and in a more advanced math class too there. So let's take a look here. How are we going to solve our quadratic equation by completing the square? By using a specific example there. Okay, so let's take a look here. This equation, we want to solve it by completing the square. Means I want to solve for x. So before we solve this here, let's take a look here. What do we mean a perfect square? A perfect square is something looks like this here. X plus a squared. That's what we call the perfect square. So when we expand the perfect square, so that if we use in the FOIL method x plus a times x plus a, so that give us, do the FOIL, x squared, x times a, which is ax, a times x, and a times a, which is a squared. So now we combine the like terms, we get x squared plus 2ax plus a squared. When we do complete the square for solving equation like this, we want our equation eventually becomes something like this: x plus a squared equal to, c there. So then when we have equation like this, when we solve it, we just simply square root both sides, get square root c plus minus c there. So then we solve for the x equals, subtract a from both sides, we get negative a plus minus c there. Okay, so that's what we call complete the square. After you complete the square, you get an equation. This equation becomes something looks like this, so then you can solve the equation. Okay, let's see for the specific example. We have this here. First, we want to keep this first two terms. On the left, we move this number to the right side. So we have x squared plus 2x. So here now, add 4 to both sides. When you move to the other side, that basically means that equal to 4 there. Okay, so now what do we do here? Because I want to get a perfect square, so I just go ahead and compare this with what we have here. So x squared, 2ax, that's 2x. And in order to get a perfect square, you need to add a squared. So you have to add some number, which is the a squared. So by comparison, you can see for this case, 2ax, that's 2. So here that means you have a 2a actually equals 2 there. Okay, I compare this with this two term. So I got 2a equals 2. So that means a equal to 1. So when a equal to 1, so here according to this means you add 1 square, that you will get a perfect square. So that means you add 1 squared, you add 1 squared there. So in other words, basically you just use this number divided by 2, take square. That's what you're going to add. Okay, that's what you're going to add there. So now you can see here, I got x squared plus 2x plus 1. This is equal to 5. So here I have x squared plus 2x plus 1 equal to 5. So now this is a perfect square. When we do this, compared to this, means this is the FOIL of x plus 1 times x plus 1. You can check there, okay? That is a perfect square, okay, which is x plus 1 squared. So now you can see I have x plus 1 squared equal to 5. I take square root both sides, so I have x plus 1 equal to square root 5. Always remember put a plus minus. This is another very common mistake people easily make and forget put a plus minus. Okay, you're going to have two solutions there. So solve this x, subtract 1 from both sides, you get negative 1 plus minus square root of 5. So now you have two solutions. One is negative 1 plus square root of 5. One is x equals negative 1 minus square root of 5. Okay, so that's how we use complete square to solve quadratic equation. Okay, so let's summarize this one more time. In a perfect square, after we did FOIL, it becomes this. And so we compare our equation. If when we get x squared plus 2x, we just compare this. Okay, we just compare this. So now we compare, and this here means you got a 2a going to be compared with this coefficient, which is 2. So now you got a equal to 1. So remember, to get perfect square, you have to add the a squared. So now a is 1, so you add 1 squared. Okay, so that's a 4 plus 1 squared. So now you have this is a perfect square, which is x plus a, which is a is 1. So x plus 1 squared. So now you got x plus 1 squared equal to 5, and you take square root. Okay, you have a solution. Okay, so now let's take a look at the second problem. This problem, the leading coefficient is not 1. In order to use the method we just talked about, the leading coefficient must be 1, means in front of x squared, you can't have a coefficient other than 1. So what are we going to do? Same method. So here, we're going to move this one to other side first. So you have a 2x squared plus 9x, subtract 1 from both sides. So you get minus 1 there. Because the leading coefficient is not 1, so we can't use the method we have there. So what do we do here? We use 2 to divide both sides. Use 2 to divide both sides. So every term must be every term. So that's divided by 2, which is x squared. That's divided by 2, which is 9 halves x. And this one divided by 2 is negative 1 half. So now, as we mentioned earlier, okay, so you consider this is x squared plus 2ax plus a squared. So now your 2a gonna be 9 halves. 2a is 9 halves. So you got a 2a equals 9 halves. So your a gonna be 9/4. 9/4, both sides divided by 2. Okay, 9/4. So now, remember you need to add a square to get a perfect square. So that means I need to add 9/4 squared to get a perfect square. You need to add to both sides. Okay, so now this is just like what we have here, which is x plus a squared. So the a is 9/4. So that means the left side is x plus 9/4 squared. And the right side is negative 1 half plus 81 divided by 16. Okay, so here we go ahead and combine these two together. So which is 1 half is 8/16 plus 81/16. And that equal to, okay, 81 minus 8. 81 minus 8, which is 73. divided by 16. Okay, so now I have x plus 9/4 squared equal to 73 divided by 16. I square root both sides. X plus 9/4 equal to plus minus square root 73 divided by 16, which give us plus minus 73. You cannot do anything here. Denominator square root denominator, which is 4. Okay, finally, I subtract 4 9/4 from both sides. I have x equals negative 9/4 plus minus square root 73 divided by 4. Okay, so now my solution is x equals negative 9/4 and plus square root 73 divided by 4. Or you get x equals negative 9/4 minus square root 73 divided by 4. So you have two solutions. Okay, that's the end of this video.